This is for Year 12 methods. It comes out of 15C question number 4, finding the interquartile range. Okay, so I've got this function which goes from negative infinity to 0 of a half e to the x. So it's going to be this exponential that only goes to there, and that will be at a half. And then it's a half e to the negative x, which is a replace x with negative x, therefore a reflection over the y-axis. So we end up with this particular pattern happening, and that's y equals 0. It's asymptotic on both sides. The total area will be 1. So sketched it, I've sketched it. Find the interquartile range. Okay, so interquartile range will be the middle 50% between Q1 and Q3. And I know that that area there will be 0.5. That's what the interquartile range means, because that's 0.25 and that down here is 0.25. Now what I do know is, because this is perfectly symmetrical, if this was 1, that would be negative 1. If this was 2, that would be negative 2. So I only really need to work out one of them. So I'll be looking at the integral of 0 to, let's call this b, of 0.5e to the minus x dx equaling 0.25, because I know that this area in here will be 0.25. There are other integrals that I could write instead of this one. I could go from here to infinity, making it 0.25. I could go from this to 0 of this particular curve, making it 0.25. But this is the one I've chosen. It is to 3 decimal places, so I'm going to use my calculator. And I've got that already in my calculator. 0 to b of 0.5 equals 0.25. Interactive advanced solve. Solve for b. And I get log base e of 2. Therefore, this here is log base e of 2, which means this here is negative log base e of 2, which means that interquartile range, which is Q3 minus Q1, is log base e of 2 minus log base e of 2, which is 2 log base e of 2, and that's the interquartile range.